So our data shaping implementation is working as expected. Let's send this request again, and this time I added a breakpoint so that we can walk through the data shaping step to see what is actually happening. So let me jump into the shape data method, and here you can see that the fields parameter contains the identifier and the name. We're going to convert this into a hash set and extract the property infos, which contains all of the properties on our DTO. In our example, this is the habit DTO. We're going to filter out the properties into just the ones that we specified inside of our fields, which are the ID and the name property, and then we're going to shape our objects using the expando object type. So I'm going to press continue, and we get our response back in Postman. Now, what happens if I specify a property that doesn't exist? For example, I just type out some rubbish, and let's send this request. We're going to land on our breakpoint, and if I press continue, we will get back a response, but we won't get a client error. Now you can decide if you want this type of request to cause a 400 bad request. In general, I think this is a good practice, so let's implement support for that. Inside of the data shaping service, let's add another method. It's going to be a public method returning a boolean, and let's call it just validate. Here I can specify my fields, and what we want to do is to again split this into a field set. So let's take the code that I had above. Now I do want to check if the fields is null or whitespace. So I will say if string is null or whitespace and pass in the fields, and if that is the case, then I'm going to return true. An empty string is valid for data shaping because it won't perform any data shaping at all. Then the next thing I want to do is to also copy the code for getting the properties of this type, which means we have to make this a generic method. So let's add a generic argument here, and now I can extract the property infos from the properties cache. Finally, we want to confirm that all of the fields inside of the field set are also present in the property info object. We can do this with a simple link statement like the one that's being suggested here, or we can say return field set, and I can use the set equals method and then project just the names of the property info objects. Now this will require me to take care of case sensitivity, so I'm going to revert to the link statement, which is doing case insensitive comparison. So now let's use this inside of our endpoint. Back to the habits controller, and for example, let's say after we validate the sort parameter, I want to check if the data shaping service validate method, and what is the DTO that we are shaping on? It is the habit DTO, and I need to pass in the fields parameter. And then let's reuse what I already had here. I want to return a 400 bad request, include the fields, and let's update the message to say the provided data shaping fields aren't valid. So now let's start the application. And let's try to send a request that contains some invalid fields, and our validation is going to kick in, and we will get back a 400 bad request where the detail says the provided data shaping fields aren't valid, and we include the field's value. So now we are also taking care of client errors when performing data shaping. But remember that the response that we are getting back isn't quite serialized correctly. Let me show you how we can fix this. Back in our program file, where we are configuring Newtonsoft JSON, I can pass in a delegate to configure the Newtonsoft JSON options. And I want to set the serializer settings to use a custom contract resolver, and I wanted to use the camel case contract resolver because this is how I want to serialize my responses. So let's start the application, and let me send the same request again with the new contract resolver, and you can see that our responses are serialized in lowercase. Let's omit the fields temporarily, and even when everything goes through our data shaping service, you can see that it's properly serialized in the response. Now, so far, we have support for data shaping when returning a collection of resources. But we can also support this when querying just one resource. So let's see what it would take to implement this in our second endpoint for fetching a habit. Let's say I add a query parameter to support data shaping. Let's call it fields, and I want to make sure to validate this, so I can copy the validation step from above and also include the data shaping service. So let me adjust the parameters here. I will add the data shaping service, which is going to come from method injection, and then I can perform the validation step at the start of this method. I will just specify the fields directly because I'm directly binding to this query parameter. And then let's say I want to do data shaping right before I return an OK result. If I try to call the method that I have on the data shaping service, you will see that it's working with a collection of entities. So we are actually missing a respective method to data shape one object. So let's go into our data shaping service and see how we can fix this. Let me first define a contract for this new method. It's going to return just one expandable object, and it can have the same name. Let's call it shapeData. Instead of working with an IEnumerable, it's just going to have one argument, which is going to be the entity that I want to data shape, and then I will try to make the implementation as reusable as I can. The only difference between shaping one object and shaping a collection of objects is this step here, where I'm iterating over the entities. So if I copy the implementation I have here and paste it here, and get rid of the stuff that's specific for a collection of entities, I will end up with just one data-shaped object. And this is pretty much what I can return from this method to shape just one object. Now, if I wanted to simplify the collection data shaping method, I can turn it into a function of shaping one object at a time. So this could be something like this. Let me omit this, and then I can say return entities select, and for each entity I can call the shapeData method, pass in my entity instance and the fields. And of course I need to call toList in the end to materialize my list of objects. But this will do some repetitive work inside of each iteration. For example, we're going to extract the property infos from our properties cache every time for all of the entities, and this might be redundant and less efficient. So I'm going to just live with some code duplication and bring back the implementation that I originally had in the collection shaping method. Now let's go back to the habits controller. We now have a method that allows us to shape one object. This will be my habit DTO, and I can pass in the fields. And what I'm going to get back is a shaped habit DTO that I can return from my endpoint. I'm also going to update the return type to be an iActionResult because it's no longer a habit with tags DTO. But now I'll run into a problem in the previous implementation because these two methods have the same signature. So the simplest way how I can solve this is by just using a different name for the method that's performing data shaping on the collection. For example, we can call it shape collection data, and we can call the respective method inside of our controller endpoint. And now I should be able to run this and test out the data shaping implementation when fetching one habit. So let me first send a request to fetch a habit by the identifier. And you can see that we get back a complete response. And now let's add a query parameter to apply some data shaping. And let's say I want to select the ID, status, if it's archived or not, and the target and frequency objects. And if I send this request, you will see that we are getting back our data shaped response that contains only the requested properties. If I make a typo or I specify a property that doesn't exist, we're going to get back a 400 bad request. So our validation is also working as expected. And let's just confirm that if I specify the same arguments when fetching the collection, the data shaping is also working as before, and you can see that this is the case. Now, a big issue with data shaping that might not be so obvious is that you can omit the identifier of the resource. So it's perfectly acceptable to fetch a habit without the identifier, and we're going to get back a response from the server. But now the client doesn't have a way to interact with this resource because it doesn't know its URI. This is something that we are going to fix with Hypermedia in our upcoming lesson, but I just want you to keep this in mind when considering data shaping inside of your API. Now, if you recall, our individual habit response also has a collection of tags. What would happen if I were to include them? For some reason, I'm getting back a 400 bad request. And if we take a look at our implementation, you can see that I'm performing the data shaping validation using the habit DTO, while I should be using the habit with tags DTO. And this is a bit unfortunate when it comes to data shaping. Ideally, we could use some higher level mechanism to perform this validation instead of introducing some silly bugs like this. Now let's see if this is working when using the correct DTO for validation. I will send the same request again, and you can see that this time the tags are properly included in the response, and I have a total of 3 tags present on this habit. One more thing you can consider when discussing data shaping is support for expanding nested resources. This can be either a collection on your resource representation or a complex object that is nested inside of the resource. You may want to omit this response in the default representation of the resource and only return it if the client explicitly asks for this. The convention for this is using the expand query parameter, which functions similarly to specifying the fields, except expand only contains a comma-separated string of values that represent expandable objects on your resource. Now, implementing this properly is pretty complicated, so you should consider if you really want to support something like this in your API. It's also closely related to data shaping, so I thought it was worth mentioning while we were still discussing the topic. We have come to the end of the data shaping lesson, which is also the last lesson in the chapter about building a RESTful APIs. Inside of this chapter, we covered many of the best practices for building a RESTful API, and I showed you how to apply them in practice inside of our DevHabit application. However, we still didn't mention one of the most important RESTful constraints, Hypermedia as the engine of application state. So that's exactly what we are going to discuss in our next chapter, which is going to be about HateOS and change management.